Welcome, everyone. Welcome to the Upstream Kernel Validation Project session here. If you guys, the print for the slides might be a little small, so if you want to see better, I would encourage you to come up. So we're going to start off by just doing some quick introductions. I'm Tyler Baker. I'm the tech lead for the Lava team, which is Linaro's automated validation architecture.
I'm Milo Casagrande. I work in the Lava team. Actually, I'm working on this project specifically.
And my name's Kevin Hilman. I'm a kernel developer in the power management team, and I also help maintain the ARM SoC tree upstream, which is why I want to see more kernel testing for upstream.
So the intent of this session is to first bring you guys up to speed with what we've done and what's currently working. But we want to focus on having a discussion of what our next steps are, what the needs are of the community for validation. And so we're kind of going to go fast through these slides in the hopes that we'll have a very, very spirited discussion here about what we're going to do next. So we're going to show some slides, and then we're going to actually show you the demo of the website and kind of walk you through so that you can start to understand what we built here. So the first part is obviously the landing page. It describes the current state of the upstream trees that we test. So at a glance, we want to focus on the failures. So what builds are failing, what boots are failing, and then trending searches. What are people looking for the most? So we can take a look at that real quick. So this is the landing page that we described. So if you go to kernel.org right now, or kernelci.org, you can see this. And this first table here is the failed builds. And so obviously it's the tree branch combination on the left here, and then this is the git describe. And then this is the def configs that have failed here. So you can see that one's failed here. And if you scroll down a little bit, the next table is the failed boot reports. So this table describes tree, branch, git describe, and the platforms that failed. There's also other bits of information that we'll get to later about lab name. This is distributed now, so we have multiple labs working together to provide these results. So the lab name there just represents one of our labs that's providing results. Obviously date, and then the failure reason, if you kind of mouse over, you'll get the failure reason, kind of just a summary. So we'll go into this more in detail, but I just want to give you kind of a quick run through of the dashboard. You guys want to add anything else?
Just for those of you who have never heard of this at all before, the background here is what we're trying to do is take several of the upstream kernel trees, so starting with mainline, with Linux Next, with the stable trees, and LSK and a few other trees. Every time there's a new branch, we build that and we boot it on a whole pile of different boards. So we're building all the different def configs, including def configs with a handful of config fragments, and we're booting it on a bunch of different boards. Distributed across a few different board farms. So the idea here is just to get a lot more testing. Right now it's just boot testing, but the idea is to get a lot more testing on the bleeding edge kernels, so mainline, especially Linux Next, and all the things that are about to go into the tree. So on the tree here is the different types, the different kernel trees that we're building.
So the next bit here, do you want to talk about this a little bit, Milo?
As you prefer. If you look at the kernelci.org, you have like a job landing page. Its terminology is not fixed in stone here. This comes out from how Jenkins works. So a job is a combination of a tree and a branch and a git describe, and it's a combination of these values for us is a job. Probably more technically speaking, it should be like a tree, just like a git tree, but gets built. The results of a job are the def config builds. So usually one job has 100 results for each. Yeah, as you can see here, we have all the available job is like actually the tree and the branch name combination, but has like a total of builds results, and each of these builds is a dev config that has been built by the kernel CI Jenkins instance. Yeah, here you can see a quick overview of all the results that we have. The build status means for each tree, that's the last, that's the total build status and the boot status for that particular job. If you click, yeah, here we'll see a breakdown of each job that has been built, the kernel that has been tested, the local commit, and the total results for that particular job. Click on that, and you get a breakdown of all the dev configs that have been built. Yeah, you can expand and see more details. Go directly to the build log of the kernel config have been used as well. And there. Yeah, you have a quick link to the boot results for this particular job and kernel combination. So you have all the boards that have been tested and all the dev configs. What do we have?
And let's get a mic here real quick.
Can you show me the screen that had the passes and fails? It had like 1,000 passes and 24 fails.
Oh, so you want the top level?
The build status, yeah, yeah, the boot status. What do the two numbers indicate? 10, 20, and 15, for example, in the first line.
They're aggregated values. So the 10 on T. Baker's tree there, 1020 means there was 10 or 1,020 boots that passed, and that there was 15 that failed.
In the last 14 days of data.
Yeah, so it's an aggregate of all the testing we've done. Now, if you want to get more specific about
On the
that-
same kernel and the same branch? Per branch?
No, it's for the tree.
That's right.
So then if you click on that, what you see here is the individual builds that we've done, and then their respective build and boot status. Any other questions? This is the confusing part, so I just want to make sure that this is clear and take any feedback if you have suggestions on how we should change this.
So if you go back to the first page, if you go back to the first page, okay, so that check mark tells you for the latest build whether it built or it didn't build, correct?
Well, it's a little bit more complicated than that, because if you look deeper here, that's kind of an aggregate of all of the mainline builds that we've done in the last 14 days, so it really doesn't tell you about the latest one.
Okay.
Yeah.
'Cause that seems like that would be a nice thing to be able to see on the front page, the latest build.
And I think we need to make that explicit, right? That this is the status of the latest one.
Yeah,
Okay.
I think so.
Yeah, listen, we'll go full screen here. Okay, so then each tab at the top of this, here, if we go back to the dashboard, this is how you navigate around. So if you click on jobs, that was the view that I just showed you. Now we're going to talk a little bit about the builds. So we'll go to that page. Yeah, sure, go ahead.
So we're well aware that there's piles of data here and it's hard to look at. So one of the things we're looking for feedback-wise is as you look at this and as you look at it even yourself, what's not intuitive, what is intuitive, how could this be presented better, because there's lots of data and we are working on, I mean, all this is just crammed into a database and we're yanking it out trying to figure out how to display it. So your ideas of how to display this easier, how to lay things out cleaner, we're told that's one of the reasons we're here, is to get feedback on this.
So just kind of the main highlights here. What you'll see on the build status is more or less what you see on the boot status. Is you see the tree branch, the kernel, the board, the def config, the architecture, and then you can query for builds. So we can show you how to do that. So if you type in Exynos, you can find the build status for any def config that has Exynos in it. So it's searchable and you can do queries. So if you want to just go to a certain view, you can just have a direct link to it and you don't have to come to the page and run a search.
Is it possible to link with the email and in the email notification?
We will get to that in a moment.
Yes, because when we build a build a warning or build a break,
Yes.
we can send an email automatically.
Yep. got a question.
So you've got an arch column there. Does that ever say anything other than ARM?
Yeah, ARM64, x86. That's the
Okay.
only architectures we have
Good.
right now.
Yeah, no.
Mike's got a question.
Right, so it's pretty obvious to me why I'd want to look at the builds or the boots, but why would I want to look at the jobs?
Because that's where the link is between what got built, what got booted, and so I think it gives you that top level view. Otherwise, you have to figure out, well, what build do I want to go look at, and what was the latest one that was built, and things like that. The jobs will get you there faster. Does that make sense?
Yeah, kind of. I've used this website before, and I've never looked at jobs, right? So like, and another piece of feedback is that what I want is today's. I want to know that green check mark if that means today.
Yeah.
You know, like that's
And
like
so-
the most important thing is whether today's boot failed or whether today's build failed.
Right. And so I think the email reporting is where that comes in.
Yeah.
This is just a way of displaying the data so that if you did want to go back in time and look at how long has this been building? Maybe I didn't look at my email reports for a while. You'd be able to go and look at this. So I don't think we're going to send developers here, but it's just kind of an interface that's there, that's searchable.
That makes perfect sense, but I thought that the green mark meant that the green check was today's is passing. Yeah.
Yep.
The latest builds.
That's the landing page. That's where we hope to.
Yeah, I've used the going back in time a few times when I saw something is broken in the latest build, and I wanted to track down for how long it has been broken, so I could see it was working 10 days ago and was broken 9 days ago, and then I could bisect between the two Linux Next versions to see where did the change come in that may have broken this, and
Right.
that's been very useful.
Yeah.
So that gives me kind of an idea that maybe you guys have already thought of, but I mean, I think it would be trivial since you have the data to know at this point this tree with this def config or whatever was building and this one it's not. You could display like last good commit.
Wait a second.
Okay.
Just
You've already thought of
this
it.
Is, no, this is great. This is perfect because
Great
we want to
idea.
answer these questions. Carlos has got it.
How frequent are you building the trees?
How many merges are there?
Yeah, whenever they change,
Yeah.
whenever there's a new push, basically. Yeah.
Yeah. So these are all good questions. We're not glancing over them. We'll come back, but that's later in the presentation. So we just want to get you show the pieces first. Okay, so the next part, it's very similar to the build side. So this view is the boots. And this is searchable in the same way that the builds is. So you can type in, Sun XI if you're an all-winter person, and you can get an overview of all the different boards. Obviously, again, the job page is probably the better place to go because it has the aggregated build information and the boot information. Okay, so let's talk about bisection because I think this was just brought up. So we do offer bisection points for builds and boots, and we can show you an example of that right now. Let's see. Okay, so here's an example of a boot failure where you'd find this, it'd give you a link in the email, the reporting email saying that there was a failure. This is on pretty much, I think, the latest Next here. Yeah, go ahead, that would be great. So what you see here is the bisection data. And so this is that nasty little clock next bug. Yes, it is. And here is essentially when we can tell there's the first good or the last good commit, and then there's the rest of the bad ones. And there's an actual script right here, if you want to click on that, Milo. That will give you a little handy helper to get you started bisecting, because we want to get this stuff fixed. Is there any questions on this? We can show a build version of the bisection if you guys are interested as well. You want to show them? Yeah.
So the other thing that's often useful is not a bisection between, especially with Linux Next, a bisection between two failing Linux Next is sometimes useful, but it's also more useful to bisect between a failing Linux Next and a known good mainline. So there's also, down at the bottom here, there's all these good commits from mainline, so you actually can get quite a few good bisection points as well. Right. Of course, the next step is to do this, to have the system do this all for you. But if sometimes it's faster, especially boot bisection, it's faster to do it locally if you have your stuff set up automated anyway. And you might be the only one with the board.
You want to show build? Yeah, we can find a failed build. Is there any other questions while we're pulling this up?
I don't know if it's available for other people to. I don't know if it's possible for other people to, join their little board farm with this, big effort. But in general, how hard would it be to get started? Is it like a massive undertaking?
So we have an API that Milo will go ahead and explain here. It's probably not really easy to do, but it's definitely, if you've already got the logs generated and you know if it passes and fails, that's the basic data. We have a schema, essentially, that here's the required values that you need to pass to the server to record a boot result, record a build result. So it all depends on how it's implemented, but we have 2 automation frameworks that work with this right now out of the box, PyBoot, authored by Kevin, and then obviously Lava. We have the support. So if you have your own automation framework and you're already doing this, then you can take a look at the API page and determine how easy that integration is. But we have a file upload API now, so you don't have to SCP directly to the server and things like that. So I think we've made it a little bit easier. Okay, so here's the build bisection page. It looks very similar to the boot bisection page, but just to let you guys know that this information is available. Okay, let's see. All right, so let's talk about the email reporting and what our plans are here. So it's an interesting problem we had to solve when we have multiple labs reporting boot results, because when do you send the email out? Do we? What's that?
Talk about the labs we have reporting in here already.
Okay, do you want to go over that? We can pull up. I don't think we do, actually. There's in the statistics page there is. Yeah. Anyways, yeah. So right now we have 5 labs that report. So my personal lab, Kevin's personal lab. We've got the Cambridge lab running a few boot tests. We've got the Collabra lab, which is running Lava, also providing boot results. Alan's lab provides boot results as well. So 5 different labs are basically their data is being aggregated in this website right now. And so the challenge was with these 5 labs all triggering at different times, when do we decide to send the email report out? And really the thing we came up with was a time limit. An hour and 30 minutes after the build finishes, the email report will be generated. So if you don't get your results in by then you're not going to be in the email report. However, you can still submit your results after the fact and they'll be reflected in the dashboard, but they just won't be in the email report. So that's kind of what we come up with to solve that problem. Want to say anything more about it? Okay. I've got it in a little bit later. So let's just give you a high-level overview of how this whole thing works, because it's just probably black magic right now. So we've got mailing list development, patch series, and then once those patches are merged, and then the upstream trees get merged together, we trigger builds on them. So we right now currently monitor 22 tree branch combinations, and they're built every time they change. So once they're built, we have 5 builders right now that will take and build every single def config and then publish the results to our storage server. From that point, the different labs will realize that there's a new build, and they'll download the binaries and they'll boot them on the various boards, and then they'll report back to the dashboard. And then an hour, 30 minutes after the build finishes, the email report goes out to the mailing list. The developers look over the results, and if there's issues, they discuss and try to fix them. Any questions on this?
Are you guys open to having new trees added in? Like, if like a subsystem maintainer wanted their tree to get tested before merging into Linux Next and potentially, pissing off a lot of people if they break stuff, you could find breakage earlier. Is that something you're open to?
Yes, we're definitely open to that, and with a preference towards these subsystem maintainer trees. Right now, we're not scaling up. Eventually, we want to scale up to just take any tree, but we just don't have the build capacity, especially for it. But we want to take the important subsystem trees as well. There's a question over here, Carlos.
The XML RPC that you mentioned before, I guess is for updating results. But here on this slide, you mentioned notifying the labs whenever there is a build. So is the XML RPC also being used for that purpose, or this notification is just something for your own labs?
The email notification, you can get email notification for your single lab if you want. The concept of the lab is only available for the boot report right now. We are going probably to extend it to the build report as well. So if you have your own lab, you can get email notification for yourself only, or for the general, all the boot reports for that specific tree and that specific kernel.
I think, are you asking more like, can your lab get notified when the build is done? How does your lab get notified when the build is done?
Yeah. We were thinking.
Yeah.
Yeah. Okay. Sorry. We were thinking about that, but we don't have it yet. So we are still.
Right now, it's rsync.
Yeah. Yeah.
We're thinking about building an API that would allow.
But it's also the problem of the timing for the email. So we don't have an API that goes back to your lab and tells the build is ready or the boot are all done and just send the email. So. Yeah.
It avoids the build duplication.
Yeah. Or
And
even,
that way,
or even
we are
boot-
100% sure we're using the same image.
Yeah. Or even boot the duplication in case if you don't want to boot the same thing on the same board for 10 times. So, yeah. It's done this one?
All right, you want to talk about that?
Yeah, okay, so I give a quick overview of the system, how it's done. So it's the two tires. We have a front end and a back end. The front end is the kernelci.org website you saw before. It's really simple at the moment, so it's a completely stateless web application. It's written in Python. Most of the rendering actually is done on the client side, so there's nothing really on the server. The web application is actually acting as a proxy to the backend. So all the data requests are done from your web browser to the backend through the front end. We have a simple cache at the moment there, so the website should be pretty fast to browse. Yeah. Next one. So this is actually where the the real work happens. It's another web app. You don't have any visualization of it apart from documentation to use the API. It's a REST API. It's not XML RPC based. We have a simple authentication method for the moment. It's just token based, so it's auth. The front end is actually using the same API you can actually query for yourself. So the front end is one of the one way to visualize this data. You can download the data and do whatever you want with it, as long as you have a token to access it. We have also, we have a couple of examples. Well, since it's a REST API, you can use Carl, you can use whatever you can use to speak to it. It just speaks and reads JSON. So you send JSON, you get back JSON. There's no over format. Maybe we can support over format in the future. And it just implements a couple, not all the HTTP verbs. So yeah, this is a really simple example of how you can get boot reports for that job, for that kernel, but all the boot report for that job, that kernel that have failed. So you will get a JSON response. You can see the schema later, and that's the simplest Python example you can have to interact with the API. Something else? Yeah.
So this is an example email report that we've been sending out to a small group of developers. So what we found was with one lab or two labs, it wasn't too bad to display all the passes. But then when we start bringing 5 together and we have 260 boot results, displaying everything was just, it was unruly. And so we decided that we are only going to report failures. And so what you'll see here is quick summary on the subject line, repeated in the body, and then links to the full report. So if you want to go and look at the reports that we were showing earlier on the dashboard, the links are provided there. And then also some metadata of what tree, what branch, the commit, all of that stuff is there. We also added some bits in there for how many unique boards and how many unique SOC families are provided in the results. And then we also, this one doesn't show it, but the interesting thing with having multiple labs is it gives us layers of redundancy. So if there's infrastructure errors in one lab where, let's say, you can't connect to the board serial for whatever reason, but other labs have that same platform, they are marked as conflicts. So if one of those labs marks a failure and some of the other labs say, no, it passed in my lab, we mark those as conflicts, not necessarily a failure, but something that needs to be reviewed in case there is an actual problem that's happening and some of the other labs are missing it. But it gives us that layer of redundancy. Say, 3 other labs are showing this board is passing and one's failing over here. It's probably not an issue that we need to look at. So I kind of slid this in here. I wanted to show you guys what I've been doing with Lava a little bit. I've been learning a lot from working with some of the kernel developers and what their needs are and kind of immersing myself in the ecosystem. And so I've been timing all the kernel boots for some time now, and we're using Lava's visualization system to start to plot these over time. Now this is a delta view, so essentially what this means is it a positive delta or a negative delta? So what you're looking for is large variations in boot time. And how I have this plotted is for the Arndale Octa platform, both on multi-v7 and Exynos def config, so you can kind of see if there's any issues that might have been introduced in one def config that's not in the other. So that's there, and then if we switch to non-delta view, you can actually see the raw data presented. So you can see that the multi-v7, since it's a larger kernel, has a longer boot time, and whereas the Exynos isn't such a large binary, so you would think it would boot a little quicker.
What's the big dip? Is that when it just didn't boot one day or something?
No, that thing there must have been some strange optimization. Yeah, so this is the other bits, right? I hope we have a conversation about when we start to do testing, how do we want to get these results displayed, and how do we deal with these outliers, and how do we know that the test results we're getting are valid? So, and then just to let you guys know, we've been doing this since LCU 14, and so these are some of the statistics that we can pull from the back end that might be interesting. So we've run over 100,000 boot tests on all our different trees, 29 unique kernel configurations, 4,166 boot failures. Across 3 processor architectures, so we do ARM, ARM64, x86. We're open to other architectures, we just don't have any of the hardware, so that's another thing. If you guys want to see your board here, it's supported upstream, or it will be shortly. Come talk to us and we can work something out. So what we can also do is profile what boards are the biggest problem. And so, here's a top 10 hit list of the boards that give us the most trouble upstream. What else you can find is which def configs are giving us the most problems. And so it's just kind of neat. I don't think we have any real use for this other than just it's kind of interesting information. So if we step down again, we can see what versions, Git described versions are most problematic. So all this data, we have this, like Kevin said, we have all this data. It's really neat, and we need to figure out how to use it. So we're going to talk about that a little bit later. Okay, so where are we today? We're still a work in progress. We're still trying to figure out what we want to do with the system and how we can make it useful for everybody in this room and the wider community. So your input is necessary in making this something that will work for everybody. Yeah, so again, 5 labs. We still have some conflicts with the bootloaders that are running in the lab and things like that. So we haven't been able to fully utilize the Cambridge lab as much as we'd like to, but I think we're hopefully going to work towards that and get us a little bit more test coverage. Yeah, so here's our lessons learned. Stuff that's noisy gets ignored, so we need to be concise, and then people seem to I don't know, absorb it more if it's less noisy. And then the other thing is automation is hard. Please don't make special tools to wrap the upstream kernel images in, because that makes us have to adopt those tools and wrap your images to make them boot on your board. Try to do things in a very standard way. It makes our lives easier. Power on boot, very, very simple stuff like this. If your board doesn't power cycle reliably, it's very hard to automate it and get good results. And if we get frustrated, we're just going to throw your board out. So let's try to do a better job on that. I think, yeah, so automation's hard. Don't let anybody tell you it's easy, because it's not. So what we want to talk about now is kind of where we want to go in the future and what's reasonable with the resources that we have. So let's address the big elephant in the room here. Let's talk about testing and where we want to start. We've learned some very interesting things from the testing that we've done. Obviously, when Next breaks into 1 million pieces, we don't want to run tests on that because we can't even boot the platform. So we need to come up with a strategy of when do we run the tests, what tests are run when, and then when do we do the big depth testing and report on those results. So our thoughts are, let's start with in-kernel testing because it's easy, right? We can do locking validation. We can do OF unit tests. We can do K-self tests. Those are easy. We can start there and do that on every boot. Well, nothing's ever that easy, right?
It's easier
Easier, yes.
than the out-of-tree tests.
Yes. And then what we'd like to do for the breadth testing is do community test suites, LTP, LKP, Trinity, those kind of things, as maybe we do it on every RC tag, right? Or some sort of cadence like that that makes sense, because what we find, and like Kevin mentioned earlier, you know, we don't have the build capacity to build all these trees yet. But if we do, we don't have the hardware capacity to boot and run long-running tests and still provide the quick boot results. So that there's a trade-off there that we need to address. And so be thinking about that. And then obviously, we mentioned earlier, automated bisection would be excellent to have. Go ahead, Vish.
One thing that I like about the direction is it kind of isolates the test infrastructure from the actual analysis part, right?
Right.
So, you know, I mean, I guess, you know, when you reported all the boot results and everything, you know, there's obviously a format in which you talk to the server. This is my boot result.
Mm-hmm.
Is there like a format that, like, you know, when you run an LTP test, what form, you know, regardless of whether I run Lava or something else, what is there a standard of, okay, this is how an LTP test needs to be reported to the server?
Well, hopefully we can find a generic way to describe any test. That would be the goal. So LTP is no different than LKP, is no different than any other test. So
Right.
that's what we wanted to find in like the next phase of this project is what's the schema look like for a test result? How do you report multiple test results? What do we want for measurements? Is it a pass-fail kind of test, right? What, you know, and collecting software context along with that, right? So the versions of the tools that were used when we ran the test so that it's reproducible, because that's the biggest problem. If these test results are not reproducible, then we failed. We need to make sure that it's something that can be reproduced.
So it hasn't been standardized yet?
No, Okay. But that's where we want to go, and that's why we need the input, right? If you've got good ideas.
Have you spoken to the guys doing zero-day build testing on kernel.org? Because they do very similar stuff, but they also run, for example, benchmarks, so you can see if you've, you know, scalability benchmarks if you've affected that.
Yeah.
And it also means that the x86 developers, for example, would have ARM build coverage, which I think they don't really have today.
They actually do have ARM build coverage now, and actually, if you really break something, you'll get an email from Zero Day long before you'll get an email from us, because it's way faster. And I've talked with the Zero Day guys. The problem is they're not willing to publish anything. They're not willing to publish anything about how their stuff works. But more importantly, they won't even publish the kernel images. So what I wanted to do is actually not do. For our stuff, I didn't care about build as much as I cared about boot. I wanted to take their build results because they're generating builds way faster than we can. But I think they're generating them so fast that it probably takes longer for them to put them someplace than it does to actually do the builds. And so they're just building, generating results, and getting rid of them. And so they're not publishing any sort of build artifacts. And so we just can't. It's hard to use their stuff because they're only publishing reporting. They're not publishing anything that we can actually take and boot. But I would love to work with that. They just haven't been, it's not open in that sense. The reporting, but the stuff they're testing is awesome, and it's fast.
I know that they, I know one thing they do to deal with the problem that you mentioned about, you know, you don't have enough hardware to run all of these things. I know that they merge, I think, everything together. So they don't just take one branch, test it, take another. I think they merge everything together, and then they pull them back out when there's a failure. But I don't know how they do it. If they're not willing to share, then I suppose it's no use guessing.
Yeah, I don't know how they're doing that either. I know they also have, you know, thousands of nodes, build nodes, and really high end, probably more than that. But another question.
What are you doing with regards to regressions?
Yell at people.
Well, yeah, no, but actually catching regressions. So we've had a partner for the last X number of years bitching and moaning about context switching. And nobody verified. And I did simple LM bench tests, and sure enough, starting from 3.4 through to 3.10, there's a pretty obvious regression with each newer kernel. Context switching was degrading. Trying to find out how we can catch that in an automated way would be brilliant.
So absolutely, and that's why we want to get your feedback on what kind of tests do we need to run, because that wasn't run until there's a problem, most likely, and so we need to add that back to the test suite. What we find now is we find memory management regressions in Next because the boards don't boot. What's interesting is there's so many things that pop up that we're kind of overwhelmed sometimes by the amount of failures that we have to go tap people on the shoulder about and say, hey, did you know this stopped booting? So we need to figure out a way to get the community involved so that we aren't responsible for going on the mailing list and saying, did you know that you broke this, or did this thing detected a regression, can you please look at it? The idea would be that if we can build this together, then the maintainers of those subsystems will look at the dashboard and they'll be able to just go ahead and
Yeah, I mean, it's tricky to work out, well, what test do I need to run? Because there's a bazillion and one test suites that you could pick and choose from. Which is the right one? Don't know.
Right.
But from like Linaro's perspective, speaking to the likes of the different groups, so LNG, etc., and getting their top 3 things that they're concerned about, so context switching, I don't know, I/O, that sort of thing. Just get the top 3 items and try and work out how best. I mean, I'm not saying LM Bench is the best thing for context switching, but it was a quick and easy way of verifying and validating the partner's concern that there's a degradation and regression.
Absolutely. Yeah, so I think we need to build up what our test plan is going to be. And ideally, what I'd like to see is tests that run very quickly. Like you said, LM Bench runs quickly, perfect, that's a great smoke test to put in there. The longer running stuff like LTP is a little more tricky because we don't have the time on the hardware if we want to provide quick boot results. So yeah, this is what we want to help define is send us an email if you've got ideas for test cases that you'd like to see ran, and we can work towards putting those in. But yeah, it's a great idea to go around to the different groups and ask them what they care about and try to integrate it.
So that sounds really great, but one issue I see is scalability, right? I mean, there's only so many people working on this, and the combination space of all the different tests that you could be running is enormous, right? It put a huge burden on you. So, I mean, it seems to me that adding new tests is something that can be done now, but also sort of enabling and empowering people to hook into this infrastructure with their own boards. I mean, so something that's near and dear to my heart is power regression testing, right? I'm not going to ask you guys to go instrument your boards for power measurement. It's something I'd be happy to help with, but I guess there has to be some effort put into making it easy for people to hook into the infrastructure. And then people can bring their own tests, right? And that way they're not asking you to do the tests.
Yep, absolutely. And I think just developing the API and the schema of how you report that is what we need to work on. And so that's what we're hoping to define in phase 2. And so I'd encourage you, we do have a weekly meeting. We can probably don't want to invite everybody in this room, but you're more than welcome to join and take part in our discussions.
Tyler, are you measuring how loaded your boards are right now? I mean, the hardware, running the boot test. I mean, how do you know which type of boards do you need? Do you keep statistics about how loaded your board, how much usage?
Oh, so like metrics on how long the board's busy?
Yeah.
I can mine that. I don't have that available to me. We did the calculation. You can divide the number of boot tests by the number of days we've been running, and it's essentially 3 boots per minute-ish. It doesn't all happen at once, but it comes in big waves. So we could definitely get those numbers and see how much extra time we have on the board.
I mean, most of the boots right now are like a minute and a half max, so their boards are not super busy.
Thank you. I noticed that a number of the boards you have here are virtualization capable, so they can either run KVM or Zen.
Yes.
What about adding VM testing to this? Because it's, one, very easy to to test. I mean, you can boot VMs a lot faster than you can actually boot physical boards. Right. And for generic kernel infrastructure, it's probably good enough. I mean, we use that a lot. Another thing is, well, I have vested interest in seeing regressions on KVM itself.
Yes.
And I think the Zen guys would have the same approach.
So I have KVM testing working in my lab. I run it on the QB truck. I run it on not Arndale Octa, XU3. So I've got a few of the KV or the hype platforms that I do. I'm just not reporting the results yet because we need to add bits for the host log for the boot and then the guest log. And so this is actually a good question. What we've kind of decided what we're going to start with is a known kernel that works on an ARM KVM. But then we're going to boot configuration, mainline configuration with all the virtualization bits enabled, and then try to bring that host up and then boot a KVM guest. Now you could go further with that and saying, well, we want to do the host and the guest on mainline kernels and make sure that they all work together. But we were going to start there, and so if that seems reasonable to you, that's kind of where we're headed. But we're not ignoring that at all. In fact, I have the capability to do it, but we need to build it into the dashboard to display it. So. Good question.
I think the other thing we want from you guys is to give us a KVM def config fragment, for example.
Yeah.
Say we're going to build multi-v7 plus this fragment for the guests, or for the host, more likely. So right now, I don't know if that's already in multi-v7, if it'll be a KVM host. But we don't have all the probably requirements for booting again. For example, we heavily rely on the title. Yeah. Right. That's unlikely to be by default in multi-v7. But yeah, so the question is whether. Yeah.
So LPA for the host is a problem. We really rely on that.
All right, you should have
So yeah, on 32-bit, LPA is absolutely mandatory for KVM. We can't do without it. So that's obviously an issue. For the guest, we should be able to boot any multi-v7 kernel. Whether it's LPA enabled or not, it's irrelevant. It should boot.
Do you see any value in booting the same kernel as a guest on multiple hardware? I don't think that's very important, right?
We've seen regressions, for example, they'll have a guest booting perfectly on an S7 and dying on an A15. That's the kind of thing we'd like to track.
Okay.
Yeah, so maybe we start by getting host KVM host support by default in multi-v7. I mean, that sounds a reasonable thing. Yeah, or in the
a few
LPA
options
fragment.
now.
Yeah. Oh yeah, because we have to have LPA. Yeah. Okay. Cool.
Yeah, I should have mentioned we have a Mustang too with that we can run those KVM tests on.
So, are there, if somebody else wanted to set up a kernel CI type environment, how, because this is all Jenkins based for the most part, no?
No, okay. I can show you the wiki page. The link at the end has all the information on how to reproduce what we've done.
Right, okay.
If you have a Lava Lab or high boots, we have to probably talk to Kevin on that one.
Yeah, it's not
So
documented.
you said that there were issues in the Cambridge lab because of bootloaders.
Yeah.
We need to.
Yeah, some of the bootloaders most of the bootloaders installed on the devices don't support Z-image, so we have to do all this crazy U-image conversion to boot the board, which is not something that we typically like to do. So, getting those bootloaders upgraded to like a mainline U-boot that supports that stuff. Some of it has the hype mode too that's enabled. Okay, yeah, that would be good. What's that? Oh yeah, and that's the other thing too. So we want to provide the quick results. So like using Juno when there's a stack of queues, right? Doesn't really work to get fast boot testing done. So we'd probably want some hardware dedicated if possible to.
Yeah, so that strikes me. It strikes me that that's the issue, because we were talking about the 0 day, the fast turnaround. That's throwing a load of hardware at it. This strikes me as the sort of thing that we need to put maybe another micro instance dedicated to kernel CI.
That would be awesome because you guys have some really interesting hardware that a lot of the developers don't have.
Yeah, exactly. Yeah, so okay, put a record.
Cool. 0 day is highly virtual. Yeah, I mean, and they're all in VMs as far as we can tell.
They don't have 400.
We got 5 builders, actually 4 now. So if you got a builder, let us know. That would be great. Okay, so this is my personal, I really want to do this. We've got all these great kernel logs laying around doing nothing, and I found something, and I was like, when did this go in? When did we first see this message in the kernel log? And I ended up grepping through all the logs, and it's not very efficient. So my thought is, what we could do is use something like Elasticsearch and load the log files into Elasticsearch so we could provide structured queries against all of the logs that we're generating. So if you say, when was the first occurrence of some message in the kernel, it would be able to look through all the logs and say, well, it was on next here, and then here's the rest of the results where I'm finding this message. So that would help the kernel developers kind of dig through the logs more efficiently. So that's one of the things that we were thinking about doing. And then again, virtualization, we're not ignoring those guys. We have the capability, we just need to work on getting that to work with the dashboard. So yeah, we kind of talked about this, how our specific lab failures dealt with. Well, we have the redundancy. We're able to say, these labs here passed, this one failed, or these two failed, so it's a conflict. We need to have manual review, but most likely it's not an actual failure. And how can I get my tree tested? We kind of went over that. We're limited by some of our build capacity, but I think the sub-maintainers would probably be the good place to start.
Yeah. Right now it's just ask. We can add probably a few more trees and not get too limited, but.
Yeah. So yeah, in the end, we.
In the previous slide, I mean, you talked about how do you go across, like, you know, lab-specific failures.
Mm-hmm.
One of the ideas that I'm thinking of, you know, why don't you have known builds with known failures? Just like you have right now, it feels like the information is upflowing more, right? You have a certain build, you download it, you test it, you push the results out.
Mm-hmm.
But what if you can certify the lab, sort of, you know, basically where you know, in order, this is the board that you were interested in, to plug that lab into your system. Okay, if we want to take your data, okay, these are the builds which have certain failures inbuilt into it, and you can check for those failures and check for the successes.
Yeah.
Why can't it be reversed? Like, why can't you say, okay, in order to get my lab in, you just run this API and your lab should be able to handle that XML RPC or whatever.
Yeah, so if I understand your question, it's you want to be able to certify a lab to say your lab's good enough to contribute.
It's a strong word, but I mean, like, I'm just saying, you know.
So that goes back to this automation is an easy thing, and this idea that people have that it's a piece of cake. It might work once, it might work twice, it might work 5 times, but 20 times later it starts failing, right? And so really what we have right now is we have labs that are bad citizens that come in, and then their lab's not very stable, and they start having failures, and what we end up doing is just turning them off, right?
I mean, you could have, like, you know, just like I'm an independent lab.
Yeah.
You could, and basically I have to implement a certain XML RPC or whatever RPC it is, and you could just do a health check on my lab every day or something like that.
Yeah, we can talk about that, but yeah.
Just random idea.
Okay, so yeah, the wiki page I mentioned about how to get started if you're curious about what tools are used, and it's a pretty thorough write-up, what trees are being built, what platforms we have, all that stuff is up there for you guys to look through. So if you go to this link, you can check it out. But yeah, we really need your guys' help to help define where we want to go with this. If this is interesting to you, come up and talk to us, and we can set up some time to chat about it and go forward. Let's see the next. So we've got some open discussion time here. Really, I think this is an interesting question. How do we want to track issues that we find? Because right now it's kind of just between us that we know what issues are out there, and we try to find the right people. But for everybody else that wants to come to this dashboard, what's a good way? Yeah, see, we asked some of the kernel developers about that, and they were like, no, we're not going to use a kernel track or bug tracker. So maybe there's some indifference between, oh, we are out of time? Okay.
I mean, one thing that.
Oh yeah, so we can, if you guys want to hang out here, we're over time on the session, but if you're interested.
I mean, one of the ideas that I have is you have to have a stakeholder for a particular failure. If you don't have that, there's no way you can track it, right?
It's more of, so stuff's failing on Next right now. We know that the issue's been reported somewhere, right? How do we display that, right? Or where is the right place to put that saying, yeah, we know everything's failing in Next on these platforms, and here's why. Here's the mailing list thread where we're talking about it. So that if somebody stumbles upon the website and looks and it's like, oh, what's going on here, they can go to that conversation, they can join that discussion and understand the problem. That's kind of what we're looking for because it's scattered about right now. So does anybody have any suggestions on how we should handle that better? I guess that it could be something that we put in to these failures, these type of failures on this build. We link back to the thread.
I think for starters, we could easily do that. This is a new failure, not one that's been happening for a long time. We need to flag those especially new failures rather than ongoing failures. But yeah, the tracking the stuff on the list or whether it's in a bug tracker some places is more open.
Yeah. So and I think this is going to become more of an issue as we start running tests.
Yeah.
And if we start running a lot of tests, we're going to have a way of figuring out, yes, this regression was detected 3 days ago and work's being done, and here's how you can get to it. I mean, and then or this is a new failure, no one's actually said that there's a fix or reported it yet. That would be really interesting to see.
With a bug tracker, the person doesn't have to use a web browser to use a bug tracker, right? You can still get emails and you can respond to emails and then, it can put it in line with the discussion. But the point is, I'd hate to see you guys reinvent a bug tracker.
And that's what we don't want to do. We don't want it to be a bug tracking system.
Have you taken this? So I know we've been talking about this internal Linaro for a while. Are you ready to take this to somewhere like ELC or Plumbers and present it to the broader community? Because then you might get more interaction. It might also put pressure on people like Zero Day to be like, oh, okay, we're willing to collaborate with you and give you our build, build output. Or is this still at the phase where it's sort of a Linaro internal project?
Well, it didn't start as a Linaro internal project.
Right,
It started as my project, and so I've been publishing this for the kernel maintainers and anybody else who's interested, been publishing on that kernel build reports list for a while. And so there is in terms of the ARM community, at least the ARM sub-maintainers are all using this and getting feedback, and I usually bother them when something breaks. But I think we are ready now to take it to a broader audience. So the core ARM developers are all using it, are kind of aware. But I think, yeah, you're probably right. We are ready to switch. So the mails that are going to the mailing list right now are still my personal mails, but after this, we're ready to switch to this. I mean, they're going to look very similar, but there's going to be a lot more boards in it. And then I think we're ready to increase the visibility and take this to ELC and start asking these same questions and stuff. But, I mean, we wanted to start here because we know there's a lot of people already using it, and
All right. If there's no more questions, I guess we can wrap up here. So thanks for coming, guys. If you see us in the hall or you want to come up and talk to us after, we'll be around. So thank you.